we are good to go. Welcome, everyone, and good evening, and welcome to the 6th Global Math Project webinar. This one is titled Learn Exploding Dots, KAPOW!
KAPOW!
Wow! Titled it Learn Exploding Dots because, as you've probably seen, it will be a live demonstration by James and Sunil on how to explode dots. So we have a special formula, a special recipe tonight for the webinar. We're trying something new, and I think it should be really, really a lot of fun. But just before we start, the usual housekeeping items. If you have questions or comments, I see you've started to type them in the chat box. That is perfect. Keep going. We'll want that. If you have any technical difficulty, you can try to send a message in the chat box. Maybe try to, I don't know if you can reach me directly in the chat box. That would be perfect. I'll try to help you because I will stay in the background. And if we run into technical issues, well, I'll just hang on and we'll try to be back on track as fast as we can. So now I will leave the stage to James and Sunil. A good webinar, guys.
Thank you, Samuel. So this is, we're trying something new and old school, and you know, we're going back to where it kind of all began, and myself or James, but we're going to be seeing, I think, the most important thing, which is the exploding dots itself. So I'm going to be, as I mentioned in the chat, I'm going to be taking as many questions as possible. I'll provide color commentary when I think it's important, and for the most part, I'm going to let James take it away now.
That's me. Hello, everyone. It's such a pleasure to be here with a live presentation of Exploding Dots itself. So I'm going to do it my favorite way, which makes it truly accessible to the entire globe. That is with next to no technology. Basically, for me, a pencil and a paper and some little chips or dots or something. But it could be, you know, sidewalk chalk in the playground with stones, as some kids do it, or it could be just, you know, drawing with, in the sand with a stick and making little holes at the end of the stick. Exploding Dots is truly, truly an accessible experience with nothing to help you, just the basics of our human selves and some primitive tools. So let's do it. But actually, before I do it, I want to prove that exploding dots can be a truly swift, enlightening, mind-blowing experience. And I need to make some comments first that I do a lot of work with students and teachers all across the globe of all levels of schooling and background and all the rest. And it never astounds me that place value is actually an extraordinarily subtle and deep concept that most people don't really get. It takes a very long time, many years, many decades, to really sit with the notion of place value before you really own it. And one thing I love about exploding dots, it actually highlights the depth of understanding one can take with place value in and of itself. So when we say on our website and so forth that you can have a spectacular mind-blowing experience with exploding dots in just 15 to 20 minutes, half a class period or something, you truly can. And one of those first mind-blowing moments for many people is actually understanding the mathematics we speak, namely place value base 10. So I want to do that. I want to get that far and a bit beyond today to show you how I actually conduct an exploding dots experience with students and adults of all ages. I'm actually extraordinarily boring. I do it exactly the same way because I really believe this way works. It actually seems to be feel free to copy it, but be your own human self. Make it your story too. Now, your story could be identical to mine, word for word, if it really resonates for you, or it could be your own version of the story. The point is to be your true human self with your audience, because mathematics, in the end, is a human conversation, so you've got to really honor that. So here goes. I'm going to talk about exploding dots, and I would not say anything I've just said to you to my audience. I will not talk about place value or bases and all the rest. The point is to let that just evolve and come shine in and of itself as we go along with the story. And if I all begins with a story, that's not true. So I like to say, here's a story that's not true, which starts as follows. Are we ready, audience? I'm assuming the answer is yes, because I can't see anything other than just my own screen, so I don't know what's going on as I blather away.
I will guide you through it, James.
Fabulous, thank you. All right, here goes. So here's a story that's not true. When I was a child, I invented a machine. And all my machine was a row of boxes that would go as far to the left as ever I desired. Let's see, is the camera going to focus on that? Camera, camera, camera. The other thing about technology is that, there we go. Oh, is it doing? Yes, there we go. And being a somewhat strange child, I decided to give my strange machine a name. I called it a 2-1 machine written in a funny backwards way, basically because I was a young child and knew no different. So there we are. I made this machine of row boxes. And the idea is you put dots into these boxes. For example, if I have 1 dot, in fact, I do have 1 dot. Here's 1 dot. Here it goes. Dots will always go in the rightmost box. Zoom. There is 1 dot in the rightmost box. So right now I just see 1 dot. It's not very exciting. It's just 1 dot. However, if I put a second dot into the machine, always the rightmost box, zoom. There's 2 dots in the machine. Then something exciting happens. Because whenever there are 2 dots in a box, they explode. Kaboom!
Kaboom!
Oh, good job. 1 dot, 1 place to the left. 2 dots became 1, hence the name 2-1 machine. Do you get it? I assume the answer is yes. All right, so right now, after 2 dots, we see no dots, no dots, no dots, no dots, 1 dot, 0 dots. So I'm going to say the code for 2 in this 2-1 machine is now nothing, 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 1, 0. Great. Let's put in a third dot. Here comes the dot number 3, always the rightmost box. Zoom. Nothing really happens. The code is now nothing, 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 1 dot, 1 dot, 1, 1. However, putting in a fourth dot, methinks, is going to be particularly exciting. Because here it comes. Fourth dot, always in the rightmost box. Zoom. 2 dots to the box, explode. Kashing! Dot. Kashloop! Dot. Wow. So now the code for 4 is 1 dot, 0 dot, 0 dots. And that's it. That's my game. I'm just going to work out codes for different numbers. Hours of fun to be had. For example, the code for 5, maybe you don't need me to actually do it, but can you see the code is going to be 1, 0, 1. Or maybe 6, you can see if I put an extra dot again, can you see in your mind's eye what's going to happen? And of course, I'm actually asking questions right now to you. I'm speaking to the void, for what feels like to me, but when I'm in the audience, this is part of the conversation. So young kids will say, okay, 5 was that. So here comes the 6th dot. They might be able to see it in their mind's eye, which is fabulous. Zoom. And 2 dots explode. Kaboom! Become 1 dot, 1 place over. So the code for 6 is 1, 1, 0. And then I personally like to mess with people's minds and suddenly ask for the code for 13. And what happens there is a little moment of disconnect because most people say 1, 1, 1 until I realize I didn't say 7, I said 13. And that becomes a great moment right there. So what on earth is the code for the number 13? I usually pause and let people play with it. It depends on your audience. A lot of people will just tell me what the code is. They recognize right away what the game is going here. And I might acknowledge it or might not acknowledge it. I might pretend I don't hear it. I might just mess with their minds and change the 1s and 0s they say. Some people actually want to try it. Most people might put in like a dot for 7, a dot for 8, a dot for 9, build up to 13. Some people might actually think to put in all 13 dots at one hit and then try doing some explosions in those, which is great. There's actually lots of ways to explore how to get to the code for 13. And a lot of people might end up saying 1, 1, 0, 1 or some other answer. I'll write every possible answer I hear on the board and usually it becomes a collection of answers and become unsure. So the point is...
There's a nice comment from Maria. I'll just read it. She said, I might give my kids a choice of sound makers for each explosion. So she wants to add auditory component of making this fun. And there's a lot of really nice comments coming in, so people are enjoying it so far. Now, I have a question for you because I don't know if you've ever done this. You're limited, obviously, by your piece of paper. Would you ever give a question like, how do we do the code for 17? If you have where it's like kids think they know what to do, and will they provide the limitation? I'm just curious because you wrote the code for 13. I think we know what the number can go into, but it'd be interesting to see if kids can go, we've run out of boxes.
I know. So sometimes I do 50. Why not?
Why not?
And that's curious. I mean, the point is that the boxes go as far to the left as your right. So it's a good moment of realization for youngsters that actually you really can draw more boxes than the teacher draws on the board. That's actually a lovely moment there. You're owning the mathematics for yourself is what the point is to the kids. And the other fun thing you do, if you really want to play with this with the audience, you can say, okay, let's go backwards. Here's a code for a number. What number is that? So going both forwards and backwards on a roller coaster is a lot of fun. Both going forwards and backwards in mathematics is also a lot of fun. But anyhow, we're just working out codes. So in my untrue story, this is just me as a young lad working out codes for different numbers in this mysterious 2-1 machine. Hours and hours of fun. And you can push it with the audience how far you want to go, how much you want to dwell on this, or move on. And I tend to move on fairly swiftly, actually, because I realized that I can say that one day I had a flash of insight. Instead of doing a 2-1 machine, I had this brilliant thought that I could actually do instead a 3-1 machine. Where now three dots explode, become 1 dot, 1 place left. Indeed, why not? Crazy. So let's do it. Put in 1 dot. Again, not very exciting. Rightmost box, zoom. Stays as 1 dot.
Boring.
Put in a 2nd dot. Here comes rightmost box, zoom. And in this machine, that's still equally boring because nothing happens. They stay as 2 dots. But put in the 3rd dot, zoom. Now 3 dots explode. Gazooble. So my explosions are very slow, sorry. Gazooble. Dot. Yes, actually, sound effects are really important. In fact, to me, making the commentary about the sound effects is really a key thing. Anyhow, so 0, 0, 1 dot, 0 dots. And then we can go on. I'll just do it very quickly here. Zoom. 4th dot in the box. 1, 1. A 5th dot in the box. Zoom. Even those sound effects are fun. 1, 2. And 6 is going to be a bit exciting this time. Not too exciting, but maybe a bit exciting. Zoom. Here it is. 6, 3 explode. Kabing! Dot. 2, 0. And if I did 13 earlier, I'd play the same tricky game. Because actually, when you say a joke twice, it can be equally funny. And often works with the audience. So we try to work out the code for 13. We spend some time fussing with that one too. And again, I'll just copy down all the answers I hear, even the half-thought ones, because my point is not so much getting the right answer, but just playing with ideas and getting lots of different answers on the board. So, you might see this, you might see this, you might see this, you might see all sorts of crazy things. I bet you'll see that as well. And great, because then I had another flash of insight. And instead of doing a 3-1 machine, I realized I could do a, and most of the audience now says 4-1, yes, or a 5-1. So the point is to go crazy. Let's go totally crazy. And here's the first flash of insight for a surprising number of people, namely all of us. Let's go up to a 10-1 machine. Totally bold. In fact, let's be extra crazy. Let's put in 273 dots into a 10-1 machine. Whoa. Now, I've run out of discs, so I have to truly do this with pencil and paper. Here comes 273 dots. I think we've got some time left on the webinar. And if you want to know my technique, if you want to know all the little jokes I tell when I give this lecture, is that I actually do this for a very long while. I'll start looking at my watch as I do it until people tell me to stop. That's enough dots. So I'll stop. There's clearly 273. You got it right. My point is, I know a lot of my audience right now knows what's really going on, but I keep emphasizing I'm a young child. I need to really think this through for myself. So let me just, bear with me. I want to understand what happens to 273 dots on a 10-1 machine. My first question is a yes/no question. Will there be any explosions? Yes, yells the audience. How many explosions will there be initially? And everyone says 27 explosions, which is great. And then I ask, will there be any dots left over? And they all say 3 dots. So that's consistently the same all across the globe. Great. So I'm going to do the 27 explosions. Gajing, dot, gajoop, dot, zip, dot, 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 27 times. Now I get a bit bored with drawing dots. And I ask my audience, is it okay if I just write the number 27 there for 27 dots? Most everyone says it's fine. And then we say, okay, and there are going to be 3 dots left over. 1, 2, 3. Now you can see this is where having a whiteboard is better than a piece of paper, but still, it's fine, we can manage. Next question, any more explosions? Why, yes, there'll be 2 more explosions. Will there be any dots left behind? Why, yes, there'll be 7 dots left behind. So 2 more explosions. Dots left behind, 1, 2, 3, 4, 5, 6, 7. And bingo, now we see that the magic code in this blurry picture, see if I can fix the focus again. This blurry picture for 273 is 2 dots, 7 dots, 3 dots. 2, 7, 3. Whoa. What's really going on? Now this is, believe it or not, a true moment of joyous epiphany. So to really understand this, to really break down what's happening, let me go back to that 2-1 machine again. And let's see if we can figure out what these machines are actually doing. Now, most people will tell me it's binary or it's base 2. They know the words, they know the jargon, but let's really think it through. I want to be really slow here. We played the game, so you put 1 dot in the rightmost box, and that's always worth 1. And that's fine. 1 dot, 1 dot, 1 dot, always that rightmost box. But in a 2-1 machine, whenever there are 2 dots in a box, that 2 1s explode, kaboom, to become 1 dot, 1 place to the left. So that means this dot here must be worth 2 of these, lasses over yonder, 2 ones. It's worth 2 ones, it must be worth 2. And 2 of these, 2 twos, kaboop! Make one of those. So this dot here must be worth, oops, can I slide my paper back down? Sorry about that. Must be worth 2 twos, which is 4. And 2 of these will make one of thoses. 2 fours is 8. 2 of thoses makes one of themses. 2 eights is 16. By the way, just I'll tell you, this seems to be universal across this planet. People like doubling numbers. They'll keep yelling me. They'll yell at me 32 next. They'll yell 64. Then they'll yell 128. Most people go up to 2048 for some reason. I don't know why you like to do that. But then we get bored, and I say, thank goodness you're bored, because I'm bored too. So we stop doing it. But my point is, what's lovely about this, because now we can see that the answer people yelled out for 13 is actually correct. And I mean C, literally C. They said 13 is 1 dot, 1 dot, 0 dots, 1 dot. Here it is. 1 dot, 1 dot, 0 dots, 1 dot. So I should have made my boxes a bit bigger there, I'm sorry. And look, we can see we're right. 1 8, 1 4, no 2s, and 1 1. 8, 4, and 1 really is 13. Yes, we got the base 2 code for 13 absolutely correct. And now it's pretty
James?
swift. Yeah.
Oh, well, I'll let you finish, but we have a nice question from one of our audience members.
Yes, tell me, let's do it now.
Okay, so our question is coming from Jill Isaacson, and I'm going to read you the question exactly the way she wrote it. And she said, would the 4-1 machines yield fractional bases?
4-1 machine.
Would 4-1
That
machine...
is... Well, I guess the answer is you have to try it. That's always
Sure.
the answer to questions like that. Try it.
Try it.
4-1. So are you speaking in my backwards way? Or do you mean 1-4?
No, I think, let's see, she said 1. Okay, so her question, I read it literally, but I think she means a 1-4 machine.
Yes, okay, all right. 1-4. This machine. So my first question is, as always about most anything in mathematics, is it interesting? Well, it looks pretty interesting to me right now. So let's put in 1 dot. Let's get the code for 1. Let's see what happens. 1 dot. Zoom. It explodes to become 4 dots, 1 place over. All right, do I have chips? Kaboom! And then explodes to become, each of those explodes to become 4 dots, next place over. Kaboom, boom, 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 boom. There's a huge pile there. Then exploding more, kaboom, boom, boom, boom. It's going to go off to infinity, bigger and bigger piles of dots. Hard to tame, hard to manage. I don't even know how to begin this. But I think I know what this lass is thinking. There's got to be something, some way to make sense of this. Maybe it's not 1 become 4. Maybe there's some version of that quarterness going on. Maybe you want your machines to go this way instead. And maybe that's getting into fractions. Ho, 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 ho. I love this play of exploding dots. That's exactly the deal. So I'll hold off for the moment on that one, but that's definitely the world of decimals, and all sorts of curious, weird things can happen. So just to continue my story, to make sure that we're on track with where I'm meant to be by 5:30.
Yep.
That's okay. Quickly again, what we do. So for a 3-1 machine, dots here are always worth 1. I think we're pretty swift this time. 3 of these, doth one of those make? So this must be worth 3 1s. 3 of these makes one of them's. 3 3s is, a lot of people say 6 right now, by the way, but I think 9's probably a bit better answer there. And then 3 9s make one of these, 27, and so on. And again, can you see which answer for 13 is actually correct? It's the 1 1 1. 1 dot, 1 dot, 1 dot. Zoom, zoom, zoom. 1 9, 1 3, 1 1 is indeed 13 on the nose. The code for 13 in a 3-1 machine is indeed 1 1 1. And then just to finish off this thought, and then we can get to the crazy stuff, which I love. Back to the 10-1 machine. Dots here are always worth 1. 10 of these makes one of them's. 10 of them's make one of these's. 10 of those's makes one of them's, and so on. 1, 10, 100, 1000. Very familiar. This is a very familiar curriculum construct. There's these base 10 blocks. You see these diagrams with various arrays of the ones, hundreds, thousands, columns, and so forth. This is essentially what's happening right now. But the point is, we really do see, and I mean now literally see, that the code for 273 is indeed 2 7 3, 200s, 7 tens, and 3. In fact, the point is that really is a shocker to a lot of people, and it's just beautiful that it's a shocker, that even when we say the number, we are literally speaking a 10-1 machine. If I write out in words 273, not many people realize we're literally saying 200s. There they are, 200s. 7T. That TY is actually, in English, short for the letter 10. 7 tens and 3. We are speaking a 10-1 machine, which is just fabulous, because the question is, why did our society choose 10-1 machines to speak with? We could actually speak in a 2-1 machine if we wanted to, or 3-1, or 4-1, but we chose a 10-1 for some reason. And, it takes a little moment of thought. And what many people then show me this. Can you see all my fingers here? Because, okay, maybe there's a mess on this. Well, I don't know what I've done to the screen. But we humans are very aware of the number 10 because of these things called digits on our hands. Is that funny? That's called a digit. We also call individual numbers digits. Have you ever noticed that? We think 10, because of our human physiology, is a very natural number to work with for counting. That's just our humanness. So I have to point out there are some cultures that actually went base 20 instead. So a good question for the audience there is, base 20, where did that come from? And the answer there is, well, that's a culture that happens to be thinking about their fingers and toes. And it's actually kind of amazing that actually we still speak a little bit of base 20 to this day. For example, I happen to be in America right now, and I know that Abraham Lincoln gave a very famous speech called the Gettysburg Address, which began as, how did it begin? Well, it began 77 years ago. And my question is, how many years ago is that actually? 77 years? Was actually 87 years ago. Abraham Lincoln speaking a little bit of base 20 then. Score is an old word for 20, so 4 20s and 7 years ago. In fact, since much of our audience is French, how do you say 87 in French? Well, I don't speak French, but I do happen to know, and I'm going to pronounce it terribly badly, 87. Set.
Pretty good.
You literally say 4 20s and 7. The French speak a little bit of base 20 to this day, which is curious. In fact, we can keep.
Let me just, we have so many nice questions here, and I think you look at the chat box and you're finished. I want you to answer this in the simplest way, almost a yes or no, because I'm sure this is like for almost like another webinar. And this question is coming from Samir. She's and said, can there be irrational bases like pi and root 3?
Oh my gosh, I so love this audience. Yes, absolutely. Yes. All right. Clearly, okay. We've got fractional bases and irrational bases. We have to address those before we finish tonight. I'm absolutely with you.
Thank you.
All right. Okay. We'll do that. The answer is yes, and I will not let you down. I will show you how. I love that inventiveness. I love that play. And normally I will go on tangents with an audience, absolutely for sure, especially with kids. If they ask me these questions, we'll go straight to it right there. I follow their lead, not mine, except for when I'm sort of under pressure to have to do a certain thing at a certain time. Maybe I'm going to follow my lead for now, but I'm going to come back to it. I can't resist joyous mathematical doing. So thank you. Yes. All right. So this in and of itself, if we did an experience like this with Global Maths, for Global Maths Week with some students, is actually a moment of epiphany and joy for a lot of people. That counts as an experience of joyous mathematics for the world. If we have people understand that we speak base 10 because of our humanness, that's a big deal. And in fact, the other thing is, the mathematics doesn't care which base we use. It's because of our human cells that we're obsessed with the number 10. Martians, happen to know, only have 4 fingers per hand. So for them, they think 8 was the very natural way to go for arithmetic, so they'd go base 8, clearly. Although I do have to point out, there are some cultures that are very aware that's a very natural and obvious way to count to 12 on one hand, and often worked in base 12. Can you see a natural way to count to 12, with your thumb being a pointer, and your fingers being used for counting to 12? I think there's a bit of a delay on my screen, but maybe you're seeing this, but there's 1, 2, 3. Each of the long fingers is actually naturally divided into 3 sections, which makes for a very convenient way to quickly count to 12 using your thumb as a pointer. It's pretty amazing. So there are cultures that are using base 12. In fact, we even use base 12 in our culture, particularly when it comes to weights and measures. How many inches are in a foot? We always talk about a dozen when it comes to baking and so forth. Why do we like the number 12 so much in trade and marketing? It's because often when you're trading goods, basic fractions like a half and a third and a quarter come up. And 12 is a very good number for dividing into halves, thirds, and quarters. 10 is actually a lousy number for that. You can divide into halves, but quarters and thirds get very awkward for 10. So often in practical life, 12 is a number that comes up a lot for a basis for a number system. Curious.
You know what's really interesting, just before I let you go on, and I think we got about 5 minutes or so, is that we've talked about so many different bases. And
Right.
you talked about early on about place value and just really having the audience and kids and teachers and anyone, just what is place value, bases, and, this is fun. Playing
This
with
is fun.
your imagination and, well,
Oh, I lost you just then. Have you gone silent?
yeah, no, we're okay.
Okay, good. Yes, absolutely. So in the remaining 5 minutes, let's address the questions that come up, because I do want to go on those tangents. I can't resist tangents. All right. So someone asked about fractional bases. So the game now is, let's get quirky. Let's have some fun. I did a 2-1 machine. I did a 3-1 machine. We did a 10-1 machine. Briefly talked about 12-1s and 8-1 machines. Now let's get crazy with the numbers. How about a 1-1 machine? Let's go down really low. Is that interesting? We'll put in 1 dot. Just try it. Put in 1 dot. Kaboom becomes 1 dot. KAPOW becomes 1 dot. Kajing becomes 1 dot. And so on. Off to infinity forever. It's kind of like that 1-4 machine. It's blowing off to infinity, hard to tame. What if I did a mixture of, say, 2-ness and 3-ness? What if I did a 3-2 machine? Maybe that's interesting now. 1 dot will stay as 1 dot, I think. Zoom. No worries. 2 dots will stay as zoom. 2 dots, because it looks like I need 3 dots to explode before they become 2. So 2 stays as 2. 3 dots. Here it comes. Zoom. 3 dots in the rightmost box. Kabing! 1 dot, 1 place over. Has the code. So what am I saying? 3 dots become 2. Beg your pardon. 3 become 2. 3 dots become 2 dots. So it's now 2, 0. 4. Zoom. 5. Zoom. Here's 2, 2. I have a feeling now 6 is going to be particularly exciting. In fact, can you see it in your mind's eye or not? Let's just do it. Here comes 6 dots. Zoom. 3 dots become 2. Kaboom! 2. Kajing! Leaving 1 behind. 3 become 2. 2, 1, 0. Well, since I played the joke before, I'll play the joke again. What's 13? Okay, so now we're doing something mighty curious. Mighty, mighty curious. Since I can't see my audience right now, and I can't see the chat room right now, do you want me to give away the answer or not to what this machine is doing? Is this some base arithmetic, or is it not some base arithmetic? And since one of our speakers, audience members, did ask about fractional bases, let me give a hint that this might be relevant to this particular machine.
So James, the answer is eager. They are eager for the answer.
Okay, so we have to. So there is a way to think through the arithmetic here. So if you go to the exploding dot site, if you go to like the weird and wild explorations in experience number 9, the very last one, I do talk about this machine. It turns out to be base 1.5. Welcome to base 1.5. This is how 1.5 looks like in base 6 looks like in base 1.5. And the amazing thing is, I didn't do the arithmetic that we do in grade school in the 10-1 machine, but you can do the same arithmetic here in base 1.5. If I want 13, I can think of 13 as 6 plus 6 plus 1. That gives me 13. Well, if 6 is 2, 1, 0, and 6 is 2, 1, 0, and 1 is 1, I can do my long addition algorithm. 2 plus 2 is 4, 1 plus 1 is 2, 0 plus 0 plus 1 is 1. The trouble is I wouldn't have 4 dots in the box. There'll be an explosion. 3 would explode to become 2, but that would leave 1 behind. So 3 leaves 1 behind, making an extra 2 dots there. You'll actually find that the code for 13 truly is 2, 1, 2, 1 in base 1.5. You can even do the same arithmetic that you learn in base 10 in base 1.5. So my point about this exploding dot story, that really dwelling on the story of place value and even going through the grade school algorithms of base 10, which we do in the exploding dot story ourselves, cements the idea is that if you want to have just quirky fun in life, and who doesn't want quirky fun in life, that all that works in any base, including base 1.5. We
And
don't have to be... Oh, yeah?
I know you're not seeing the audience's chat, but I think just after you did that example and the answer, Samir, mind-blowing, Karen Bloom, wow, Gail Tanner, whoa. I mean, it just went off. Yeah.
Okay, and since someone asked about an irrational base, let me just end off the day before I make my final comment saying, I'll give you an example of something that turns out to be an irrational base. One dot explodes to become, two dots explode to become, now I'm confused. Now I'm confused about myself. One dot explodes to become one dot and one dot. What I mean by that, in a machine, feel free to place any dot in one spot with two dots to its left. And that's a machine that's operating in base phi, the golden ratio. Whoa.
Whoa.
So if you get very funky, very quirky with how your rules go, you can get to all sorts of strange bases. Golly gee, but that's a lot. That's a lot for an audience. So that's amazing, audience. In half an hour, we got that far. But my point is, for Global Maths Week, I just implore you, I invite you, please, have a first experience, a first beginning experience of, say, even just the story place value in base 10 with an audience sometime during that week. Let's bring that first mind-blowing moment, and a bit more if you've got the chance and the means to, with an audience. Let's bring it to a million students of all ages, youngsters, adults, the whole range, sometime during Global Math Week. Just have that first experience. Go to explodingdots.org, register, let us know how many people you intend to work with, and have those people count. It's worth registering so you actually know you're a part of that million. Have your city shine up, have your country shine on the map, and know that we are having a global phenomenon over shared joyous mathematics all across the planet in the same week. I mean, joyous, true, uplifting mathematics really can transcend borders. So let's prove that. Let's prove that in October 10th to October 17th. By the way, I don't know if you've noticed, but Global Math Week is actually 8 days long because we're being inclusive. It's both the 10th and the 17th counts. So I guess we're quirky all the way through.
Well, I think just by judging by the audience's reaction, and I posed a question, I didn't poke you. I mean, I just typed it in sort of silently myself. I said, I think what a great idea would be to continue this webinar because we went into so many wonderful nooks and crannies of, exploding dots and base machines. And I think I just posed a question with the audience, like to have this continue for our next webinar. We'll discuss it, but I think the reaction is pretty overwhelming.
Can you see my thumbs up?
Yep, I see your thumbs up.
That idea. Yep, I'm into that idea. That's good.
Okay.
Oh, brilliant. Thank you, everyone. Thank you, Sunil.
Hello again,
Super.
guys. Can you hear me?
Hello.
Yes.
Yes, I
Hi,
can.
Stan.
Amazing. Hello. That was really amazing. I was looking at the chat during your presentation, James, and it was going crazy. So there's definitely a lot of interest for more exploration, I would say. And as you said, Sunil, we will be looking into what could we talk about in the next webinar in September, right, James and Sunil? So maybe if people want to let us know on social media, send us emails at info@globalmathproject.org. And also, I wanted to make sure that you guys let the audience know what they can do if they haven't registered and where they can reach out to you guys if they have comments and things to say.
Sure. James, go ahead.
Okay, well, clearly one needs to go to explodingdots.org to register. If you feel a little bit shy and need to learn some more, go to the frequently asked questions there and you'll see a question that's something like, what are exploding dots? That will lead you to all our materials about how to understand them, read them, do them, watch videos for yourself, and do them with others. But in the end, have an experience. You've actually done step 1 of the process, learn something about exploding dots, register, pledge to do something with some students of any age, life students that is, during Global Maths Week. That'd be brilliant. To reach me, My Twitter handle is @JamesTanton. Very obvious. If you know my name, you know how to reach me. And if you just Google my name at this point, I think you can reach me or find my email address on the web. I'm very easy to reach.
Super. I just typed in my Twitter handle at Math Garden, and yeah, just again tell people to go to the, www.globalmathproject.org, and we've got, I think, almost 80 countries now and over 300 ambassadors, and it's really picking up speed. And I think just by the enthusiasm in our chat room, there seems to be this excitement. And I know that Global Math Week can't come fast enough, but I'm really enjoying all this build-up.
Excellent, excellent. So let's do it.
I can add one last little detail. So the guys here at BuzzMath, we're developing the online experience for you people to enjoy really, really soon. We're working really hard on that, and we're so excited on our end also to share that with the world. If you want to hear more or poke us or send us questions, we'll be more than happy to chat with you guys and answer your questions. So I've put the Twitter handle for BuzzMath right there also. Please don't be shy to send us messages on social media.
That's the lovely thing. So you can do this with no technology like I do, or you can go to the full fabulous technology experience with BuzzMath. I mean, we've got the whole range covered. However you like to do your maths, we've got it for you.
Super.
Yeah, indeed. Thank you very much to all the attendees, people that have shown up for this webinar. I hope you had a good time, and we will let you know about the next webinar that will probably be kind of similar to this one with a little twist, maybe. We'll see. So we'll see you soon.
Okay.
Thanks, everyone.